Welcome to Mobile Coding Academy. Learn principles, build confidence. Let's dive in.
Welcome to your custom deep dive. Today we are opening our notes on Android Compose to answer this lingering question from last time. What exactly is a recomposition scope? Because, as developers, we are obsessed with boxes.
Oh, absolutely. Everything goes into a neat little container.
Right. Like we put logic inside a function, then that function goes inside a class. We expect nice, neat walls. So when I look at Jetpack Compose, I just assume recomposition scopes are doing the same thing.
Like they are just another box?
Yeah. If I think about a coroutine scope, I know that is a literal container managing cancellation. So my intuition is that a recomposition scope is just another container that owns UI elements.
And I mean, that intuition is exactly what gets developers into trouble.
Really? It's not a container.
Not at all. What is fascinating here is that the word scope is kind of a trap. A recomposition scope is definitely not a lifecycle container holding your UI, and it does not have physical walls.
Okay, so if it's not a box, what is it?
It is simply a restartable, re-executable unit of composition work.
Okay, let's unpack that. Because without those walls, how does Compose actually know what to restart? Let's say you have a typical LoginScreen composable, right?
Right. Standard setup.
Yeah. And inside, there is an if statement checking an isLoading flag. If it is true, we show a spinner. Otherwise, we show the login button. I normally just assume the literal Kotlin curly braces around that if block act as the boundary for the restart.
And that makes sense visually, but the braces are just syntax. The actual boundary is defined by observation, specifically the state read.
The state read, so just the act of looking at the variable.
Exactly. When you read a mutable state, like that isLoading flag, the Compose runtime actively records that action. It looks for the nearest and closing restartable scope up the UI tree and effectively subscribes it to that state object.
Ah, I see. So reading the value at the very top of the login screen means that entire screen becomes the subscriber.
Yep. If the state changes, that whole block gets invalidated.
But, okay, what if I pass a lambda or defer reading that isLoading state until I am inside a smaller child composable, like, say, a login content button or something?
Well, then the child composable becomes the subscriber, not the parent. You have narrowed the focus.
Oh, wow. So the parent login screen never actually read the state itself.
Exactly. So the runtime completely skips the parent during the next recomposition, saving all that redundant work.
That is incredibly efficient. So let's track what happens when that isLoading flag actually flips to true. My brain wants to believe the app synchronously halts and redraws the UI the millisecond the value changes.
Right, like an immediate repaint.
Yeah, but given that Compose is built for like 60 or 120 frames per second, it must be batching these updates somehow, right?
It is, yeah. If we connect this to the bigger picture, a state change is not a synchronous command to redraw.
So it does not instantly repaint.
No, not at all. The underlying mechanism relies on the snapshot state system. When you change the value, the runtime looks up all those subscriptions we just talked about and marks those specific scopes as invalid or dirty.
Meaning they are pending. Like the runtime essentially just adds them to a to-do list for the next available window, rather than doing the work right then and there.
Exactly. A to-do list managed by the Recomposer. The Recomposer waits for the platform's next frame signal.
Like the choreographer on Android syncing with the display refresh rate.
Spot on. When that frame window opens, the Recomposer sweeps through that list of invalidated scopes and re-executes only those specific blocks of code.
Wow. So what does this all mean for you, the developer listening to this? Placing your state reads carefully isn't just, a style choice or clean architecture.
No, it directly manipulates this pipeline. By deferring where you read state, you dictate exactly how much of your UI gets added to that Recomposer to-do list.
Which keeps the app running efficiently. You are wiring up listeners, not just putting widgets in boxes.
Precisely. It requires a complete shift in your mental model from visual layout to data dependency.
Oh, that makes perfect sense. Well, we have established what gets restarted when state changes, but this leaves an important kind of provocative question for you to ponder.
Oh, I know where you were going with this.
Yeah, if Kotlin curly braces do not actually create the boundary, who or what actually decides that a specific piece of composition work is restartable in the first place?
It is a great question.
Here's a hint. The Compose compiler is pulling the strings behind the scenes. Something to think about until our next deep dive.
Thanks for learning with Mobile Coding Academy. See you in the next deep dive.